a remarkable insight provided by the James Webb Space Telescope. It found what appeared to be city lights in space, located 7 trillion miles away from Earth. The genesis of this extraordinary discovery lies in an interest in the possibility of life on other planets. The telescope centered on Tauri b and Proxima Centauri b, revealing the closest exoplanet to Earth. Strangely, bright lights were observed emanating from it. What could have led to these cities? Could the lights on Proxima and Tauri b indicate the existence of extraterrestrial life? Join us as we investigate how the James Webb Space Telescope uncovered these extraordinary occurrences in space. Scientists and the general public have long considered the possibility of life beyond our solar system. Now, there is compelling evidence supporting this aspiration. Excitement has greeted this exploration. Recently, well-known scientists were shocked when the James Webb Telescope appeared to detect clear evidence of life in space. While investigating the universe and transmitting data back to Earth, the telescope observed odd, city-like lights flashing from the exoplanet. These lights, originating from Proxima Centauri b, suggest the illumination of a faraway city. The possibility of an alien settlement on this star has left researchers awestruck. Could this be the long-awaited breakthrough? If so, many believe it might suggest the existence of intelligent organisms building civilizations beyond the bounds of human comprehension. And now, we may just be beginning to find them. 7 of these city-like lights were examined. Billions of miles away from Earth, NASA scientists are left wondering how long these lights have been shining in space, waiting for humanity's technological advancement to locate them. David Kipping, a Columbia University specialist, describes the exoplanet Proxima b, where the city lights were discovered, as amazing. He mentions that the system, which is the closest to us, exhibits warming patterns different from typical rocky planets. While planets are known to absorb sunlight, Proxima b emits significant infrared radiation. These differences in infrared emissions from its host star, Proxima Centauri, hint at fascinating characteristics. The JWST, James Webb Space Telescope, which can detect frequencies in the infrared, uncovered a distinctive heat signature on Proxima b. This plays a crucial role in revealing the secrets of its environment. Thanks to its cutting-edge infrared imaging capabilities, researchers will use the JWST to investigate the planet's atmosphere. It is anticipated that the JWST will help evaluate the possibility of life on this exoplanet. Its ability to detect infrared light allows it to observe what happens on Proxima b's night side, picking up even the faintest beams of light in the vast darkness. Although this has always been a challenge for space telescopes, the JWST excels at detecting even the tiniest emissions, making it the best tool to determine if the rumors of cities are true. The night-side lights of Proxima b suggest the possibility of artificial illumination. Any such light can be recognized by the telescope as long as it falls within a frequency band that is 1,000 times smaller than that of starlight. Proxima b also has a fascinating relationship between its celestial components and surface features. The exoplanet's day side is covered with numerous solar panels that absorb sunlight. It also reflects light at the spectral edge of its star's energy. As Proxima b completes its elliptical orbit around its host star, it goes through day and night cycles similar to those on Earth. It experiences intense solar heating during the day and plunges into the frigid night as it rotates. Known for its temperature variations, the composition of Proxima b plays a critical role in shaping its climate. Without an atmosphere, the temperature difference between the day and night sides would be extreme. Gases are essential to moderate this, preventing the day side from overheating and the night side from freezing. This temperature variation is an important subject for astronomers. It offers valuable insights into the atmospheric composition of Proxima b. Using the JWST's unmatched infrared imaging capabilities, scientists can evaluate additional data on thermal emissions and gain crucial information about the planet's atmosphere. The JWST's Earthbound orbit aligns with Proxima b's orbital period, allowing for in-depth evaluation of its day and night cycles, completed every 11.2 Earth days. Since Proxima b is believed to have an atmosphere, the next step is to examine its chemistry and assess its ability to sustain life. Key indicators of life include the presence of gases like water vapor, oxygen, and methane. If these substances are discovered, they could indicate habitable conditions. However, the process of capturing and analyzing the light passing through the planet's atmosphere remains challenging, even for the JWST, due to its limited capacity for distant observation. Despite these limitations, astronomers are excited about the introduction of new ground-based observatories like the Extremely Large Telescope, ELT, which is expected to be operational in 2028. The ELT will be able to study atmospheric structures in more distant exoplanets, providing essential information on their potential habitability. NASA scientists and the public are looking forward to future space telescopes. But for now, the JWST remains a crucial tool in our quest to understand the mysteries of distant exoplanets. Although powerful, the JWST can study only a limited number of nearby exoplanets in detail. That's why scientists are also planning for future instruments to block out the overwhelming brightness of a planet's host star, much like shading your eyes from the sun to better see a distant object. This method would allow telescopes to focus more effectively on exoplanets, providing clearer data about their environments and potential for life. However, this approach comes with challenges. Astronomers must distinguish between gases produced by life forms and those resulting from geological or atmospheric processes. Those that are the result of geologic processes, such as eruptions from volcanoes, are difficult to study. Despite these difficulties, astronomers are determined to improve our knowledge of exoplanets to find evidence of life beneath the surface and to distinguish real findings from potential false positives. The James Webb Space Telescope, JWST, symbolizes a glimpse into the future of advancements in exoplanet science. It provides a window into the remarkable discoveries yet to come as we continue to investigate the cosmos. No exoplanet has yet been discovered and definitively demonstrated to contain life. The continued search asks, are we the only ones in the universe? For centuries, individuals have wanted to know if intelligent beings exist beyond Earth. The age-old query persists, and so does the search. In 1984, Jill Tarter and American astronomer Thomas Pearson began an endeavor known as SETI, the search for extraterrestrial intelligence. This non-profit effort continues today as scientists examine spaceborne radio transmissions. Radio signals are more suitable for traveling long distances without degradation. Yet despite over 3 decades of signal monitoring via radio telescopes, no conclusive alien signals have been detected. Still, Jill Tarter remains optimistic about the potential of the JWST in this endeavor. Launched in December 2020, the James Webb Space Telescope is considered the most advanced imaging telescope in infrared history. It is outfitted with cutting-edge technology that uses light to penetrate cosmic dust and uncover the universe's secrets. The JWST's primary mission is to investigate the universe, searching for the earliest galaxies and stars that existed billions of years ago. Its instruments include a near-infrared camera, a mid-infrared device, and a fine guidance sensor capable of capturing faint light from distant objects and maintaining precise positioning in space. Since its launch, JWST has produced stunning images and revolutionary data, offering new perspectives on the universe. Much of the attention has focused on exoplanets and distant stars and galaxies. The discovery of what appear to be city lights in space has prompted researchers to reconsider the possibility of life on other planets. Proxima Centauri B's discovery of such lights has been particularly surprising. The JWST's investigation continues, with its unparalleled capacity for deep space exploration bringing humanity closer to answering one of the most fundamental questions of all. Are we alone in the universe? Scientists continue investigating the enigmatic city lights of Proxima Centauri b. The next steps involve closely monitoring the light emissions from this exoplanet. By studying fluctuations in the light over time, scientists hope to determine whether the patterns suggest artificial sources, such as those generated by electrical grids or other infrastructure. Long-term observations are crucial, as they may reveal whether these lights are the byproduct of intelligent life or an unidentified natural phenomenon. Researchers will also continue studying the atmospheric conditions of Proxima Centauri b and its host star. The planet's magnetic fields and atmosphere might play a role in producing effects that appear as city lights to the JWST. Whether these lights are artificial or bioluminescent in origin remains unknown. Some scientists believe they could signify advanced civilizations. Others suspect they might come from organisms that produce light naturally. In either case, the possibility of artificial illumination from a distant exoplanet challenges our understanding of the universe's limits. As the search for life beyond Earth continues, The discoveries of lights on Proxima Centauri b and Tauri b have opened new avenues for scientific research. The next phase will require careful analysis of the planet's light emissions to determine whether they exhibit consistent patterns that suggest intelligent design. The importance of this research lies in its potential to confirm or dismiss the existence of intelligent life. The JWST's capacity to observe Proxima Centauri b will continue to be vital. As technology advances, scientists will develop even more sophisticated tools to investigate distant exoplanets. Future space and ground-based observatories, such as the Extremely Large Telescope, ELT, will enhance our capabilities to gather data and detect weak signals that the JWST alone might not capture. These new instruments will form a collaborative network, enabling astronomers to focus more deeply on exoplanets than ever before. This will improve our understanding of the universe and bring us closer to confirming life beyond Earth. The search for intelligent life on distant worlds has already made significant progress. While the discovery of lights on Proxima Centauri b is compelling, the concept of alien civilizations remains speculative. Each unexplained or baffling light emission brings us one step closer to answering the question: are we alone in the universe? If future research demonstrates the possibility of intelligent life, it could usher in a new era in human history, one of understanding, cultural enrichment, and technological transformation. Even without conclusive evidence, the journey of scientific inquiry is invaluable. Every step forward in our comprehension of distant worlds contributes to the greater story of humanity's quest to understand the cosmos and its mysteries. The discovery of life beyond Earth would have profound consequences, not only for science, but also for philosophy, society, and our perception of our place in the universe. Knowing we are not alone could shift our worldview, challenge our ideas about intelligence and life, and inspire international collaboration across disciplines. Until then, the search continues, driven by wonder and curiosity, as humanity looks to the stars for answers. As NASA and other space agencies examine the JWST's data, they remain hopeful that the mission will reveal the universe's deepest secrets. Every discovery, whether or not it finds evidence of life, brings us closer to our ultimate goal: understanding our place in the cosmos and the possibility of life beyond Earth. In the coming years, space exploration will progress with new technologies, telescopes, and missions. These efforts will allow us to learn more, observe distant exoplanets in greater detail, and pave the way for revolutionary discoveries. Whether it's the detection of extraterrestrial cities, strange light emissions, or the exploration of distant worlds for signs of habitability, the journey to uncover the truth about life beyond Earth is still in its infancy.